Alright guys, let's start off with some timers now. We'll start off with an on-delay timer. I did a video a couple of years back on the different types of timers, on-delay, off-delay. So I will have it either previous to this in the playlist, or I will have it linked in the comment section below. So let's start off with an on-delay timer. We need to put in an extra rung here. So I'm going to click here, and then I'm going to click over here on rung, and that's going to bring in a separate rung. Then I'm going to use an XIC, so I believe we were grabbing our XIC and XIO from the favorites folder. It's also available here in the bit logic folder, right? So here we have our XIC, or examine on. There's our examine off. I'm going to grab an XIC, drag it down until I see green, and let her go. I'm going to have this labeled the same as this output number 2. So when output number 2 turns on and goes from a 0 to a 1, then I want this to be true and turn on my timer. I've shown in the previous video that you can click this, go through to your local 1:0, go to the data, and then grab that bit. But I'm also going to show you now that you can, if you have that already set up, you can grab it, drag it down till you see green, let her go, and now output 2 will be sending the signal into my timer. Where are the timers found? Well, they're found right beside in the timer and counter folder. And we'll start off with an on-delay timer. So again, we'll grab this guy, we'll drag her down till she's green, let her go. Okay, I'm going to call this guy timer 1. Not sure at this point whether spaces are allowed here in the name or not, so I'm just going to leave timer 1 as my label there. Okay, I'm now going to right click on this guy and click new timer 1 to create the tag. Okay, so here it says create new parameter or tag, timer 1, so we'll hit create. Beautiful. As soon as we do that, then we're able to put in the preset and the accumulated. You'll notice that previous to that, if I just put in timer 1, I wasn't able to put in the preset or the accumulated value. We're not putting in the accumulated value because that's going to accumulate as it times out. But we are going to put in the preset. And if you've seen any of the videos that I've done on Siemens or on Bradley, the time base is usually in milliseconds. So let's put in 5,000 milliseconds, which will be 5 seconds. Beautiful. Okay, if we go to here under main program or parameters and local tags and double click on this guy, now we have the timer 1 that's available. So we can you can see down here I can monitor those values, or I can edit the tags there. Okay, if I click on the arrow that's right beside the timer there, it brings up all of the bits that are associated with that timer. So we have the preset, the accumulated, the enable, the TT, and the done. So if you've seen the Siemens program or Siemens videos on the TIA portal, they don't have the TT, but the Allen Bradley does have the timer timing bit as well. So we have the accumulated, the enable, the TT, and the done bit. And we've just changed the preset value to 5,000. So we're going to add in the enable, the TT, and the done bit in our program so we can monitor those guys as it plays out. You'll see that above, it's always backwards, above I've got the PLC. On the previous videos I was saying, like, check out these LEDs here, right? And there's no way you were seeing them. So I thought I'd zoom in on this one and show you the actual PLC so we can see the bits change as we change our inputs and our outputs there. Okay, going back to our main routine. So 2 ways we can get back to our main routine. Up here, you have this tab for the main routine, so I can get back there by clicking here. I can also click over here on the main routine. So if we had started off and you couldn't get to your previous program, then you click on tasks, then you would click on main task, and then main program, and main routine is where you have your program. Okay, so we'll click that, double click it, I guess, to bring it in. Okay, so now we need a couple of the other parameters here. So we're going to do 3 different parameters. So we'll throw in 3 different rungs. That looks good. Okay, and we'll put in an XIC. So we're going to go back to the bit logic. So we're going to put an XIC into XIC. Let me show you how to change that because I just screwed that up. Okay, so we'll click on this guy. So I'm double clicking on the instruction, and I want this to be an XIC, so I'm going to change this to examine on. Beautiful. Okay, so now I want to have a number of different outputs turn on in each rung. Okay, so I'm just clicking on each rung. I could have done copy paste, like done one rung and then done copy paste. Okay, so we had output data 2. Let's do output data 3 here. So going into our data here, we'll do 3 here. This guy, we'll do 4. All right, so I'm going to the first word, and then going to data 4. Beautiful, and this guy's going to be data 5. So we're going to have different lights turn on when different parameters within the timer are enabled or go to a 1. Okay, so next one is number 5. Beautiful. Okay, this one here, I'm going to, let's see if I can type in, there we go, I can type in timer 1, gorgeous, and it brings up my timer 1. Okay, but specifically I want like a specific bit in that word there, right? So you can see here that on the bottom that I have timer 1 now, and I'm going to click on that guy, and I have the preset and the accumulated value. I'm going to look at the enable. So think of the enable as the coil for the timer. For the time, having a problem talking today. For the timer, enable for the timer. There we go. Okay, so timer1.en. Okay, I'm going to do the same thing here. I'm going to type in timer1, and then I'm going to put a dot at the end or a period. Okay, that brings up the preset. Let's see if I can go. I was wondering if I could do the up and down arrows to choose those guys, but I could not. So I'm going to choose the TT bit now, so the timer timing bit. Beautiful. And then I'm going to click on, so different ways that we've done this, right? We typed in timer 1, then we went and found it. Then I'm going to click here, click on the drop down menu here. That brings up all of my bits that are available. The timer is down here. So we use the enable, the TT, and now we'll use the done bit. So enable is like the coil. So when the coil of the timer is energized, the enable bit will go true. The TT bit is the timer timing. So as the timer is timing out, that will be true. And the done bit is when the timer has finished timing, and that would be the same as the contacts changing state on the timer there. So we'll do the done bit there. Beautiful. Okay, let's quickly change our main operands here for data 3. So this is our timer 1 enable bit. Beautiful. This guy here is our timer 1 en, our enable bit. Nice. And finally this one here is our timer 1. That's going to be our done bit. Excellent. Let's scroll up so we can see everything. All right, so it looks like we've got everything. There's no red on the page here, so it's not angry with us. So let's try and download this to the PLC. Okay, keep in mind that I do have my RS links up and running, right? So I do have on the Ethernet channel here, the PLC 192.168.1.10. So get your RS links up and running if you haven't already. Let's minimize this guy. Let's go up here to communications, who active. Okay, there's my PLC 192.168.1.10. So let's download to the PLC. Okay, we're going to hit download. Okay, now it says done downloading. Change the controller back to remote run. Yes, excellent. Okay, so now we're live here. We have our rungs that are green. Everything's good to go. Okay, sweet. So we're all set up. So we've got our normally closed stop push button. That's changing state there. Okay, we're going to momentarily hit the start push button. But before we do, let's walk through what we think is going to happen. This one's an on delay timer, right? So when we hit the start push button, that's going to turn on output number 2. This will latch output number 2 on, which will also keep this one true, which will send a signal into our on delay timer. So on delay timer gets the signal, right? So the signal will come in. Once this is true, then our enable bit should be true at the same time, right? So as soon as this is energized, the enable bit should go true. And at that point, the timer will start timing out, right? It's going to time out for 5 seconds. At the end of 5 seconds, then the timer timing bit will go to a 0, and the done bit should go to a 1. Okay, so we're going to see those values hopefully over here as well here in the monitoring tags. All right, let's see what happens here. Okay, so I'm hitting the start push button. Okay, that turns on our output. Okay, we're now timing up there. You can see that the accumulated value is changing. Nice. Okay, we got up to 5,000. And we can see that the enable bit is still true, right? Because this is still true. And now the done bit has set. Nice. And the timer timing was live while the timer was timing out to 5 seconds. Okay, let's hit the stop push button. Okay, that takes our accumulated value down to 0. So as soon as this is no longer true, then this reverts back to 0 there. Beautiful. Let's walk through that one more time, guys. There's our stop push button. I'm going to enable the timer. Okay, it's timing out. Enable and TT are both at 1. Once it gets to 5,000 or 5 seconds, then the TT goes to 0 and the done bit goes to a 1. Beautiful. We can see those values here as well. So I had your viewpoint here. Let's just take a look here at the values for the timer as well as we change that state there. Okay, so everything goes back to a 0. Okay, turning the timer on now. You can see the accumulated value is going up. Enable TT are 1, and it gets to 5,000, and the done bit sets. Beautiful. So again, think of the enable as the coil. TT is the timer timing, and then the done bit is the set of contacts on the actual timer changing state there. So most of the time we're going to be making use of the done bit. Excellent. Okay, let's go offline and let's take a look at the next one. Let's take a look at the off delay timer. Okay, so let's come up here to see where it says remote run right here. So we'll click on this guy. We'll go offline. So we'll look at how to do like online edits in a little bit. But at the moment we're just going offline and we're going to change this bad boy to a TOF timer. So a timer off delay timer. Beautiful. Okay, that's all we've done, right? So we changed it from an on delay to an off delay timer. Okay, we've now made a change. So let's go communications, who active, click on this guy again and hit download. Again, there's other ways to do this, but let's stick with the same way for now. Okay, that will download our change to the PLC. Okay, now it's asking us to change back to remote run. So if it doesn't, it's going to ask you that, but if it fails to ask you that or you forget to turn it on, then remember you can change it up here. Okay, let's hit yes. Beautiful, now we're on. Okay, so we still have timer 1, right? Timer 1 has now been changed to an off delay timer. Okay, on the previous one where I looked at the on delay timer, like I said, I was going to show you these LEDs and then I neglected to do that. And even now with the light shining on it, it's really hard to see. So let me turn off this light and then we should be able to see the bits coming in there, right? So that one there, that's changing state. So that LED right there is my stop push button. Okay, then the next one for input number 3 is going to be my start push button, right? So that's going to turn on the timer. And then you can see the bits associated with the timer are turning on there on the bottom there. So you can see me flashing the start push button there, and you can see the associated bits below. Okay, so let's take a look at this this timer first. You can see it's timing down now, but let's go through the basics of this guy first. Okay, let's set her back to our standard state where the normally closed stop push button is closed and it's just waiting for the start push button to be pressed. When the start push button is pressed, output 2 will turn on, which will send a signal into our off delay timer. So whenever the instructions preceding the timer are true, then the enable bit will turn on, right? That's like the coil of the timer, right? But it's also the bits prior to the timer need to be all true in order to enable that timer. Okay, so that enable will turn on. What else will turn on? I believe the done bit will turn on at the same time as well, right? Because so for an off delay timer, when you energize that timer, the contacts change state right away. Well, the bit that's associated with those contacts or that mimics those contacts is the done bit. So when this XIC is true, the signal will be sent into the off delay timer. I believe the enable bit will turn on and the done bit will turn on as well. Okay, Then we'll have to hit the stop push button, right? Because we'll have to eliminate this input into the timer. The off delay has to be turned on or enabled and then turned off or remove the enable on the timer, right? So for an on delay, you send the signal into the timer and it starts timing out right away. With an off delay, you have to send the signal into the timer and then remove the signal. Once the signal is removed, then the timer will start to time out. So for an off delay timer, you'd want that like on a cooling fan or something like that, where the machine has been running. You turn the machine off, right? So you send the signal in to turn the machine on. You're now removing that signal to the machine, but you want the timer to remain timing for a small period of time in order to cool off the unit there. All right, guys, so let's do this. So we got the off delay. You can see there that the stop is closed at the moment. We just need to close the start push button in order to send the signal into our off delay timer. So let's do that now. So I'm just momentarily pressing the start push button, letting go. That latches in this output, which keeps the input into the timer as being true. So here we can see that the enable bit has been energized, or it's true. So that's the analogy as being the coil of the timer. So we've now energized the coil of the timer, and with an off delay, the done bit or the contacts, the analogy being the done bit being the contacts, they've changed state right away. Okay, nothing happened with the TT bit, and no timing has happened on this timer yet. That's because we need to make this true and then make it false, right? It needs to go true and then false in order for the off delay to start timing. We do that by hitting the stop push button. So let's interrupt that circuit. At that point, we can now see that it's timing out, right? The timer is now timing out. The done bit is still set during those 5 seconds. And then as soon as the accumulated value is the same as the preset value, then the timer stops timing out. The enable bit is now is untrue because the signal going into it is false as well. Timer timing out has timed out, and then the done bit being the contacts of the timer have now reverted back to their rest state. Okay, let's watch this again, guys. So we'll watch it here, and then we'll watch it over here. So initially, the enable bit and the done bit go true. Beautiful. Okay, we let go of the input to the start push button. This is still true to our off delay, so we need to eliminate that signal. At that point, the enable will go to a 0. The TT bit will start to time out, so it'll be true. The done bit will stay true until the preset, the accumulated value are the same, at which point all of these guys should go to a 0. So we'll do that by interrupting that signal right now. TT bit is true, done bit is still true up to the point that we get to 5 seconds, and then they kick out. Beautiful. Okay, looking at the monitoring of the tags as well. One more time, we should see that as soon as we hit the start push button, okay, then the enable and the done bit go true, okay, being seen here by the ones. And then as soon as we interrupt that input to the off delay timer, then the enable bit goes to a 0, TT bit goes to a 1 as it's timing out, done bit stays as a 1 until the preset and the accumulated equal each other, and then everything goes down to a 0. So seeing that, so we're looking right here one more time, and you can see the accumulated value going up as well. Okay, up to the point that we're at 5 seconds, and then everything goes to a 0. Beautiful. Okay, so everything's mimicking with the off delay timer. There is one more timer though, so let's go offline. Let's change this timer, and then we'll download the changes to our PLC. Again, we can do this, I believe, on the fly, but I'm going to go offline first. And we'll change this to the third timer here. Okay, so it looks like out of the timers we have an on delay, an off delay, and now we have the retentive timer on. If you recall from the on delay timer, if we remove the signal, then the cumulative value went straight to 0. So there may be some applications where you want to keep track of the time between your 0 and your full accumulated value. So this would be your instruction to do that, right? Because both the on delay and the off delay timer, being the TON or the TOF, as soon as the signal is eliminated, then the accumulated value goes back to 0. So this is remember that this is an on delay timer, which allows us to retain the value if we've removed the signal into the timer. Let's take a look at that guy. So we've got an RTO. Let's just download that to our PLC. Excellent. So now we're up and running. We can see here that we have not sent the signal into the timer yet. Our accumulated value is at 0. Okay, so if I hit the start push button, so I'm just going to do this quickly. I'll hit the start push button, and then I'll have to hit the stop quickly in order to bring the signal in and then eliminate the signal. And normally that would bring our accumulated value right back to 0. Right, as soon as that input to the RTO, to the TON timer went to 0, then the accumulated value would go to 0. Let's see what happens here. So we'll hit the start, and then we'll hit the stop here. Okay, so I've now brought the signal into the RTO, then eliminated the signal. Normally the accumulated value would go to 0, but in this case I'm at like 1.8 seconds, right? So it retains the value within the memory. You can see here that the accumulated value is stuck at 1866. Okay, if I bring the signal back in, meaning that I hit the start again, then it's going to accumulate from there, right? If I stop it again, then it stops at the value I have here at 4050. So anytime that you stop the retentive timer, retentive on delay timer, it will retain the value within the accumulated value. Okay, so we'll hit the start one more time. Okay, gets to the 5000, and you can see here that this is similar to an on delay timer in that once it has timed out, the enable bit stays true as long as the signal to the timer stays true. So I just limited that by hitting the stop. And then once the timer has timed out, then the done bit sets, right? The done bit sets when the preset and the accumulated value are equal there. The issue is that now it's at the accumulated value, and because it retains that value, I don't have a way right now to reset the accumulated value back to 0. So let's go offline, let's add something else, another instruction, and then we'll be able to reset that value because at the moment it's retaining that value forever. Okay, so we need a way to reset the timer. Well, within the timer file folder here, we have our on, our off, our retentive timer, and we also have a reset instruction as well. So let's see, maybe we'll add another line down here. Okay, so we'll add a rung in. Can you still see that? Yeah. Okay, and then we'll put in an instruction here. So we'll have a bit instruction here. We'll have to have another input there as our reset there. And we need this bad boy. Let's go back to timers and counters. Let's grab the reset, and we'll bring that bad boy down until we see green. Looks good. Let's have this as a new input. So let's see, we had input 2, input 3. Okay, let's do input number 4. Okay, easy now. So let's go to the data here. Okay, so we'll say input number 4. Okay, and we'll change our main operand description. Okay, that's going to be our reset push button. Excellent. And then that guy's going to go to this instruction. So when this is true, that will reset. And then we're just going to click on here, and we're going to choose the timer, specifically our timer 1, right? So if you have a number of timers, you'll pick the one that you want to reset. And we can reset the, let's just try and reset the whole timer and see whether that works there. Okay, so let's download that to the PLC. Excellent. Okay, so in the going offline and then going back online, it looks like it's reset my accumulated value here to 0, but let's see what happens here. So we've got the RTO still there. We'll hit this start. Let's have this ramp up to the 5000. Beautiful. Now the done bit sets. Okay, let's eliminate the input to the timer there, but the done bit is still set, and it looks like our accumulated value is still set at 5000. Okay, so we have our reset button on input number 4, which is, you can't see that, I have another dip switch that I'm going to make true. So we'll take a look here. That should reset the timer, and we should see that this value goes to 0, and we'll also see again that obviously these two will coincide, and they should both be going to 0. And once that is once the accumulated and the preset are no longer the same, then the done bit should also go to 0 as well. Okay, so watching this one right here, and at the same time watching these values, or right here. Okay, so hitting 4 right now. Beautiful. Nice. Okay, so we didn't have to specifically choose like the accumulated value. We just reset the whole timer there. Okay, so as soon as I hit that number 4 and that was true, it reset the accumulated value. Okay, one more time for good measure, and then we'll finish off, as usual, a very long video. Okay, so we've got the start push button coming in. That starts our timing. We're going up to the 5,000. Beautiful. Our preset and accumulator are the same. So now the done bit has set. Let's hit the stop push button, which will eliminate the enable. Okay, we're still stuck at 5,000. So the done bit is still set. So we're going to hit the reset push button. That's going to reset the timer, and we'll take a look here, and we'll see that the value goes automatically to the rest state of 0. Okay, so hitting the reset button now goes to 0, beautiful, and the done bit is now untrue, meaning that the enable, the TT, and the done bit are now at the 0 state there. Excellent, guys. All right, so that covers the 3 different types of timers, right? We have our on delay, our off delay, and the retentive timer. On and off are the ones that are going to be used the most. The retentive timer, possibly you're making use of that for some applications where you want to keep track of runtime or anything like that. You'll see, like when you get into variable frequency drives, that they do keep track of the timing that the actual drive has been on and the timing that the output to the motor has been on. So you can grab that value there, or you can use your PLC in order to keep track of your runtime of your motors there for maintenance and stuff. All right, guys, thanks very much again for sticking with me for a very long video. We'll stop there, and I believe the next one we'll look at are the counter instructions. Thanks very much, guys. We'll see you guys soon.